Hello and welcome to our presentation. Today we are going to talk about the painting techniques of the Eastern European Chalcolithic based on some recent experiences doubled by archaeometrical analysis. First, let us introduce ourselves. We work or study within the ArchaeoInvest Center and the Faculty of History of the Alexandru Ioan Cuza University of Iași, Romania. Full-time archaeologists and part-time experimentalists, we share a common interest on the technology of prehistoric ceramics, with special emphasis on the spectacular Cucuteni-Trypillia pottery. Within the many groups of the Old Europe, as defined by Maria Gimbutas, the Cucuteni-Trypillia stands out for its constructive and technical economic achievements, as well as for a mystery aura still surrounding the makers of this civilization, regarding first of all the absence of necropolises for the most part of its evolution. Among others, it is characterized by the adaptability and systematic organization of the settlements, from the small ones, 10 to 20 dwellings, to the giant settlements of its eastern area of hundreds and thousands of dwellings. Its wattle and daub dwellings are also noteworthy, with massive clay platforms built on wooden structure, often 2 stories tall. The construction keep inside their walls a very rich inventory, witness of household and/or specialized crafts, and of the spiritual artistic concerns of the Cucuteni people. In relation to the latter, probably the most significant vestige of the Cucuteni-Trypillia culture is the sophisticated painted pottery. Throughout the more than 1000 years of evolution, even if constantly changing, the bichrome or trichrome painted ceramics have remained a constant. Starting with phase A, there are mostly spiral and meandering motifs, red on white or white on red, that were usually framed with black. In the Cucuteni A-B phase, the painting is characterized by the gradual transition from the negative decoration, spared from the background of the vessel, the engobe, to the positive one, painted on this background. Another characteristic is the predominance of bichromia, the black color having an important role. Also, the painting is marked by the first schematic painted anthropomorphic representations. As for the last phase, B, the vessels are painted much more sober, in one color, mostly black, occasionally red, usually on a white yellowish engobe. Sometimes there are 2 colors, red bands framed by black on white. Along with these representations of the basic motifs, there are also more schematized anthropomorphic and zoomorphic silhouettes, often arranged in metopes. The Cucuteni painted pottery has been the main focus of countless typological and stylistic studies, quite a few technological archaeometrical studies, and close to none experimental approaches. So, what do we know at this moment? First of all, there are millions of painted shells in the museum and tens of times more still lying in the ground, so they must have painted their pottery. What were the colors used? There are various nuances of red, white, or rather yellowish white, and black, rather dark brown. The white is usually, but not always, used as a background, an engobe. The surface of the painted vessels is usually carefully smoothed and polished, most likely over the paint. How do you think they did it? The popular a priori opinion among the Romanian archaeologists is that the pigments were grounded and the powders were mixed with organic liquids, milk, egg, blood, vegetal oil or juices, melted wax, etc., and or water, applied on the pottery with various brushes and other tools, followed by the firing, 800 to 1000 Celsius degrees, which helped the paint to adhere to the walls. Somehow, on the contrary, a few Russian researchers argued that only the engobe was applied before firing, while the actual painting, using egg as binder, was applied after firing and covered with a coating of wax. What did they use as raw materials for painting? Here, the answer is quite clear, thanks to the quite numerous different analyses applied to the paints, using different techniques in different laboratories. The table you see synthesizes most of these analyses. The red row represents our own analysis, made on a few shells from the recent excavations in an eponymous site. Summarizing, the red paint was obtained from iron oxides, minerals like hematite or red ochre. The black paint comes mostly from iron and manganese oxides like jacobsite, haussmannite, pyrolusite, and the white comes from calcium compounds like calcium carbonate, calcium silicate, kaolin clay, or more rarely from titan dioxide, rutile. These minerals were all available at the time, of course some more than others, in the areas occupied by the Cucuteni-Trypillia people. What tools did they use? Here, since most of the materials used were perishable, the archaeological evidences are rather discrete. However, there are a few clues in the archaeological record, and the painted toolkit from Dumești is the most noteworthy one. In a rather small, globular, painted vessel, several pieces of hematite and jacobsite, along with a polishing stone and two clay paint brush handles, were found together. The handles keep imprints of the fibers which made the brush, probably animal hair. Hence, even if obvious, we know for sure that they used paint brushes and polishing stones. So, what else could be of potential help? Of course, ethnographic analogies. Of the not so many living communities which still paint their pots, the Native American Pueblo people and their ways are absolutely noteworthy. Why? Firstly, because most of their pottery gives us a déjà vu feeling, the shapes and the paint and decoration being close to the Cucuteni-Trypillia repertoire. Secondly, they still do it today the traditional way, or so they say. Thirdly, because there are thorough accounts of the techniques and raw materials dating from the first decades of the 20th century, when, most likely, the craft was not tainted by the contemporary technology and shortcuts. Fourthly, the craft, as well as the people, evolved and survived on the same place for more than 2000 years, since the emergence of ancestral Pueblans, aka Anasazi, around 1200 BCE. In short, the Pueblo potters shape and thin their pots by the coil and scrape technique. After a thorough smoothing, the potters usually add a white slip, a clay of higher quality based on calcium silicate, in several layers. With or without slip, the surface is then carefully polished, and only after that it is painted. The colors, basically the same black, red and white with several nuances, derive from either mineral, manganese, iron oxides, or vegetal, the so-called carbon paint sources. Once painted, the vessels are ready to be fired. Going back to the Cucuteni-Trypillia painting, we should mention that some small-scale experiments were made previously in Romania and in Ukraine. Regarding the one from Romania in 2007, they tried to use some local clays from the area of the eponymous settlement, Cucuteni, for the red and the white, and commercial manganese oxide as pigments. These were dissolved in water and applied on completely dried vessels without prior or post-polishing. Their conclusion, obviously, is that, and I quote, the painted surface of the vessels did not get the polish specific to painted Cucutenian ware, end of quote. On the other hand, and I quote again, the experiment proved that the colored clays used for pigments yielded very good results, suggesting the possibility of being the ones used by the Cucutenian craftsmen, end of quote. The Ukrainian experiment in 2018 took place near the other eponymous settlement, Trypillia, and consisted on testing local clays and minerals used for red and black paint, as well as some techniques and various types of brushes for applying the engobe in the painting. They also tried to test the hypothesis of engobe before and painting applied after firing, followed by coating the surface with melted wax. Let me just say that, like so many stories imagined a priori by the archaeologists, this works fine in theory, but not so much in practice. For the time being, we haven't dug too deep elsewhere for pottery painting experiments. We wanted to keep a certain innocence about it, to perform based mainly on the archaeological evidence, instinct and common sense, and not to be biased by others' experiences. This is one of the reasons why we tend to call these first attempts experiences rather than experiments. Also, instead of looking for answers, we rather tried to find the proper questions. Since the intention was to reach a certain know-how first, we used already powdered, commercially available iron and manganese oxides and calcium carbonate. The same goes for the different sized brushes and most of the clay. We also used some local clays from near our archaeological base. The paints were applied on small clay plates as well as on several vessels. Before painting, the plates were smoothed, polished on different stages of drying, with or without engobe. The pigments were mixed with water, milk, egg white, yolk, mixed egg, clay suspension. From all the above resulted dozens of combinations. We objectively measured the colors of the paints on clay before and after firing with an X Pro 2 color sensor. The plates and the small vessels were fired in an electric kiln at 900 Celsius degrees, and the big ones in an outdoor experimental kiln built also last year. Samples of archaeological and experimental pottery were studied by optical microscopy, scanning electron microscopy coupled with energy dispersive X-ray analysis, and micro-FTIR transform infrared spectroscopy. We started enthusiastically with a small vessel. On its smoothed walls, a rather thick, of cream consistency engobe was applied, composed of egg white, water, and calcium carbonate. After drying, it was painted with red and black pigments mixed just with water, also fairly thick solutions. The result, looking quite good, was fired in an electric kiln for a couple of hours at 900 Celsius degrees. Did it work? Of course not. The red and black did not bond to the engobe, which did not bond to the pottery surface. Moreover, the engobe partially exfoliated, being too viscous because of the organic compound. We had the same result on the clay plates, but without organic binder in any of the colors. After that, a long series of trial and errors began. With or without prior polishing, with or without engobe, with several recipes for both the engobe and the paints, nothing seemed to work. Well, we did achieve, however, some really bad smells, resulted from the alteration of our pigments mixed with organic binders under the August heat. Here are some first attempts at bounding the painting and the engobe to the clay body by polishing over. Because of the viscosity determined by the milk, egg, etc., that didn't work too well either. At this point, we happily got out of the way and far from our noses the hypothesis of organic binders. We moved then in other direction. We thought that maybe a more liquid solution of fine clay mixed with the pigments will adhere better on the clay body, both as engobe and as paint, also allowing the polishing over. And indeed it did. We took some fine-grained clay from the vicinity of our base and levigated it. The purified clay was mixed with the pigments and applied on the smoothed clay plates. This recipe proved to be valid, as the engobe and the painted lines allowed a light polish over, done with a smooth pebble. After the firing, these plates passed the finger rubbing test, no color being affected. Also, the texture, shining, and color nuances could pass for a very indulgent observer as somehow close to the Cucuteni-Trypillia pottery. We applied the same technique on some life-sized vessels, with the same apparently positive output. These vessels were fired in an experimental construction inspired by a Cucuteni kiln discovered recently at Stolniceni, Republic of Moldova, going above 850 Celsius degrees. Unfortunately for the ceramic art, but fortunately for science, the large bowl cracked during firing. This allowed us to submit some samples to analysis without committing any crime against the pottery kind. In the FTIR spectra, the manganese oxides were identified. It is also visible that the structure of the clays has influenced the manganese pigments. This could also be another good sign for our recipe, manganese oxides mixed with levigated clay, since prior analysis on Cucuteni-Trypillia black pigment show relatively low concentration of manganese and the presence of aluminium silicates. We are far from being able to draw clear conclusions, since it is obvious that we have a lot of work ahead of us. Identifying mineral pigments around the Chalcolithic settlements, preparing them for painting, building and using accurate toolkits, testing ourselves the hypothesis of painting after firing, and so on. But still, these attempts proved us that either no organic binders were used, or it is a magic beyond our skills. The Cucuteni-Trypillia pottery shows signs of polishing over the engobe and the painting, so the Pueblo way of painting over the burnished engobe doesn't seem to have been also the Chalcolithic way. The analysis somehow proved the validity of our hypothesis, but it should be repeated on more archaeological and experimental samples, even as blind tests. Anyway, we feel that we are on the right track to find the true colors of the Cucuteni-Trypillia painted pottery. Hope this was interesting to you, and we look forward to provide updates. Thank you.